Well, thank you all for coming. For the last 3 days, we've had a rather terrific meeting, I think, starting with some pretty sophisticated discussions of how we come to know whether we're measuring people's beliefs or their knowledge, to presentations of some rather remarkable work done by people who are associated with the projects that the National Science Foundation has helped us organize, but also done by people who, finding out about our work and our approach, have wanted to share their work with others. And I think this is in one of the great traditions, frankly, of both democracy and science, which are conducted in public, and in which sharing of things and work and getting the appraisal of colleagues and friends is an integral part of both democratic practice and scientific practice. This is an annual event that we do. In part, we did it because we wanted to find an opportunity for people from colleges around the country to have a chance to express to their representatives here some of the value that they were taking from their part of the National Science Foundation's investment in improving education. This is something that you can also do at home in your own districts, of course, but it is something that we thought gathering folks together might give a sense of just the depth and the diversity of activities in which you're all engaged. And so I want to thank all of you who brought your work here, both to share in the panels and in these posters. Years ago, we decided we wanted to hold out to the attention of others work that was truly extraordinary, and we wanted to honor that work in some way on behalf of all of us in the community of some 3,000 people who've been involved with the Sensor and National Center projects, and the colleges who have been part of us, and now high schools and museums and aquaria and zoos and the National Park Service and everyone else who somehow decided to associate themselves in some way with the work that we're trying to do together. And so we also wanted to honor someone who had been integral to our development as an idea and work, and that was William E. Bennett, after whom we named the Bennett Award. Interestingly, we had an idea about what that award should do, and our community changed that idea, and this has been a hallmark of the work that we have done over the years, and I think it's very consistent with scientific and democratic practice. That is to say, when you invite other people into a discussion, you have to be prepared to change the outcome that you originally thought you might have. And so we thought this would be an individual, that we would give this award to a person. And then we got a call from someone saying, but haven't you been trying to stimulate collaboration, and why aren't you giving this award, to a team, or could a team apply? And so we said yes. And so, as it turned out, this forced us to purchase 2 plaques a year instead of 1, but it did give us an opportunity to both recognize extraordinary individual work and extraordinary collective work. So today, I want to tell you that we're carrying this just one step further, in that when we created the award, we also said that we thought we might, on occasion, provide this award to someone whose leadership had been inspirational to all of us, even though his work wasn't immediately proximal to us. Not somebody from our community necessarily, but someone who had made it possible for us, had a hand in making it possible for us to have such a community. And so we'll be doing that today in honoring Congressman Holt, and in accepting the honor of having him be here with us. But I want to use this opportunity, though, to just tell you about our other 2 honorees from this year, and in fact invite one of them to say a few words before Congressman Holt is able to speak, or speaks. I think in this room he'd probably be able to speak whenever he wanted. But so this year our individual award went to a remarkable person, Dr. Gary Booth, a professor of plant biology at Brigham Young University. Gary may have contributed more items to our assessment work than any other professor, because he's used our assessment materials, which are also developed with the National Science Foundation's support, ever since we began doing them. That's the Sensor Sound that many of you have heard about. He's somebody who's received an award for creating civic engagement activities in the state of Utah, who helped form a consortium in the Western Consortium of Schools that the Keck Foundation is supporting for us. But those are just sort of activities that he's been involved in. What is truly amazing is his inspiration as a scholar and teacher, and for, I think, his remarkable ability to use the work of his students when they're doing research, when they're further along in their careers, to bring that research back into the introductory courses as students speaking about their research to illustrate what that has to do with the canonical learning that's going on in the biology class. Senator Hatch, who's his senator, wrote him a letter to congratulate him upon receiving this award. And in the letter says the key thing that makes us and made us want to give this award to Gary, and that it uses the word love. The love of students, the love that he gets back in a kind of allegory of the three graces, you might say. He gets back more love even than he puts in. And this isn't a soppy statement. This is simply the truth, that when in writing one of the letters of nomination for him, one of his colleagues said, "I always knew I wanted to be a teacher, but when I met Gary, I knew what kind of teacher I wanted to be." And so I want us to hold Gary in our thoughts now, and I will maintain, and several of us maintain, pretty close contact with him. He has been a true hero in our work. The group award went to the core interdisciplinary team from U.S. Military Academy at West Point, and this is sort of by way of sort of a military reenactment, I guess. So I'm supposed to pretend that I'm giving you this award now, Craig. If you'll come up here. Even though this was brought down from West Point for the occasion. We were desperately worried that we might find it in some sort of pawn shop. But Bill, would you please come up here and hand this back to them? This is William Bennett, the person for whom the award is named, and Bill will say a few words at the end of today's ceremony. I've invited Craig not only to take this and have his picture taken with Bill, but also to, for all of us, and especially for you, Congressman, to give a little bit of an account of the work that they did that makes this award so incredibly appropriate. And we're deeply proud of what you're doing. Thank you so much. I guess does it matter?
The United States Military Academy at West Point for extraordinary contributions to citizen science, 2014 Sensor Summer Institute.
Bill, you go ahead.
Perfect, thanks.
Okay, great.
Well, Representative Holt and Mr. Kidd and academic colleagues, I really appreciate the opportunity. It's an honor to say a few words on behalf of a very large core interdisciplinary team at West Point. And when I was looking over the venue for today, and I realized I had the honor of sharing a little bit of time with Representative Holt, and I saw not only a distinguished career of service to the nation, but he's a physicist. And I thought that was pretty cool, because I come from the Department of Physics and Nuclear Engineering at West Point, and we call ourselves the House of Pain, Physics and Nuclear Engineering. And that has a mixed effect on the cadets. But we like to say that PAIN is weakness leaving the body, and PANE is knowledge entering the mind. And we get somewhere with that, I would say. But when I read the congressman's background in plasma physics, I thought, there's an area of work that is so fascinating, because I'll mention in a minute a little bit about the core program at West Point, but every cadet, regardless of what their academic major will be, takes 2 semesters of calculus-based physics. Sometimes, for some of those, and I think this crowd can understand, Newton's second law may not inspire them to the level that we had hoped. But when you say something to them like, hey, guess what? When we go to Mars someday, we may be going on a plasma thruster to get us there. And then they perk up and get excited about the discipline and realize that there's some really neat stuff behind physics. And yeah, we need that underpinning of the 17th century to get us there. But the applications of today, like plasma physics and lasers and all the stuff that they find cool, is a great mechanism to get them engaged. But the real reason that I have a few minutes to talk is there's a couple of reasons why we were able to be successful at West Point in integrating the core curriculum. And I use that verb integrate because that word shows up in our overarching academic program goal at West Point, to integrate across a curriculum where 3/4 of the curriculum is common to all cadets. And so essentially for about the first 2 years, they're all going down the path of taking a very robust core curriculum, and then they select their major, and then there's still some core curriculum left to take, but then they go off and they do their specialty in something that they're passionate about. And then you look at the mission statement of West Point that says, to create leaders of character prepared for a profession of excellence and service to the nation. And you look at the work that Censor does about leadership and education and civic engagement and responsibility. It nests beautifully with our mission statement at West Point. So I can say that from the great collective best practices that the Censor group has been able to bring to us and help us, and the great support we've had from the Department of the Army. I mentioned Mr. Kidd at the beginning, Deputy Assistant Secretary of the Army for Energy and Sustainment, a huge, huge supporter of what we're doing at West Point to change the culture of energy management at that very highest level, Department of the Army. But we're creating the leaders that are going to be at the head of that Army in 10, 20, and 30 years from now. So we've had tremendous support from Mr. Kidd and from Censor to really bring to bear not only the best practices of all of you, but we mentioned briefly the SALG and survey. How do you assess, how do you know if you're doing this right? How do you know if you're having any effect whatsoever? That's something that takes a lot of expertise. And David, I can't thank you enough for the support we've gotten on how you do this and how you do it right. So I mentioned a little bit about that core curriculum. I'll tell you the projects that we've got at the, I say plebe and yearling year, but in everyday language, that's freshmen and sophomores. We call everything something different at West Point. I'll try not to bring out too many of those odd acronyms. But so the plebe year, we brought energy as what we call our spine, and it's a thread to use as a vehicle to integrate the curriculum. And there's no better one to use right now if we're really trying to change the culture of energy use in the Army. Mr. Kidd and I were speaking just before we came up here for this, and talking about the days when we first entered the Army, when energy was considered something unlimited. When I was a lieutenant, my first duty assignment was when I was a lieutenant in my first duty assignment in Fairbanks, Alaska, when we went to the field, it was cold. And so if we went to the field for 10 days or 2 weeks, I never turned off my Humvee, ever. And because that was the warm place. And when it got low on gas, you just took it to that medium-sized tank and you filled it up. And when the medium-sized tank got low on gas, they brought a big tank and they filled it up. And then who cares what happened from there, but it just kept coming. And so we were in an era of unlimited resources. So really when we get at these cadets, we're really changing a culture that's your military leadership in decades down the road, and the response we've had from them has been phenomenal. So in that first year, we used a system that's relatively new to the Army called SWIPE, Soldier Wearable Integrated Power Equipment System. And it's a way to take an apparatus that's literally wearable for the soldier, and to be able to recharge the batteries of all the things that they need power for when they're on a mission. And it reduces the battery load significantly. And they had to pull together the various courses that they take that plebe year: math, chemistry, psychology, English. And you think, well, how's English going to fit into that? Well, because they have to write about it, and they have to tell us how they're going to make an annex to operation order to change the culture of their unit to use this new power management system and to use it effectively and to be a good steward of the resources we have. And that particular project went off very well. And then we decided, let's get somewhere toward the run stage of integrating your knowledge across a curriculum. And the run stage, in my view, is here's the problem, ready, go. The crawl stage at the freshman year was here's the problem, here's a couple questions that are really relevant to the problem, and here's the classes where you're learning the answers to those questions. So in between, we said, let's give them a problem and let's give them some questions, and then they have to reach to their curriculum and pull together some ideas on how they're going to manage it. So in the second year, the sophomore year, keeping with that energy thread, we gave them a problem in a U.S. city of meeting peak power needs with alternative energy using either solar or wind. And the city we picked was Santa Fe, New Mexico, and the reason we picked that was because it was a data-rich place that one of our instructors in the geography department had a whole lot of information about. And it's also an area that doesn't have a right answer, and that was part of our goal. And that drives cadet, I mean, you can imagine, it drives all students nuts. And we get a bunch of type A people in this classroom and say, we're gonna give you a problem, and then they come and they say, did I get it right? I don't know, did you get it right? And so there's an interesting dynamic that happens there. But we use that as a mechanism for them to say, you know, it's okay if you really think economics is where is what you want to study as a major at West Point. It's awesome if you want to pick physics to study as a major, or engineering, or literature, or any of the 40-some majors that we have. And we're not trying to diminish the need for specialization. But the problems that our leaders will face in the military and outside the military are very complex, and they're very ill-defined, and half the time the problem is identifying the problem. What is the question we're trying to solve, and how are we going to go about solving it? And yeah, I'm going to need disciplinary expertise, but what disciplinary expertise am I going to need, and how am I going to leverage it? So we brought these cadets in teams together, and they were just, you know, we didn't look at their majors, we just assigned them randomly to a team. We said, here's this problem. You work for the governor, and or the mayor, I'm sorry, you work for the mayor of Santa Fe, New Mexico. We need to look at meeting peak power needs with alternative energy. Wind or solar are our options, ready, go. And then they had to look at that this is not a physics problem. There's a big physics part to it. This is a political science problem. This is also a psychology of the people of the land problem. This is an economic problem. This is a geographic problem. And those are all courses they happen to have in their second year at West Point, and also mathematics. And when you're going to project power needs, there's a lot of statistical analysis there. And we watched them go, and it was amazing to see when they integrated the problem at that level, how excited they became about a discipline that they were trudging their way through prior. Like, I got to get through physics. Okay, I got to get through this math class. Well, if you really like political science, and then you realize how the physics and the mathematics leverages a decision to be made when it's integrated with that political science, then you have a whole new appreciation for what it means to integrate across a curriculum and why that robust curriculum exists. It's not because we want to make you suffer through a course you didn't want to take, which kind of is the view when they go into it. But when they come out the other end, it's usually very different. And through some of the tremendous assessment tools, we get to ask them questions at the end about what they've learned about integrating across these disciplines and solving a very, very real problem of energy, not only in our Army, but in our nation, and they're excited. They're excited about what they're learning, and we're really excited to take them to the next level, which was that run stage, maybe we call it first year, senior year, we bring them back together, and not only do they have that core curriculum to leverage now, but they've also got some disciplinary expertise. The engineers have had some engineering, the physicists have had some physics, and the political science folks have had some advanced political science, and then they really can pull together a team and leverage each other and know what questions to ask, because when you hand them the real problem, they've got to come up with those questions. So I thank you all. It's been a pleasure to walk around and look at the posters and see how everybody's tackling the same problem. And I'm walking back to West Point with some ideas I've gotten from all of you on the posters, and that's what this is all about. So I thank you for your time.
Thank you very much. What got us into this project originally was an interest in HIV disease, which June Osborne called multidisciplinary trouble. And what I think you've heard from Craig is how we're working on another multidisciplinary trouble of energy. They have to go energy net zero at West Point by 2020. Every single person they graduate is supposed to be a personal energy manager, whether she or he goes on in the military or finishes the duty they have to the military and goes into some other line of work. We are here to honor someone who has to deal with multidisciplinary trouble all the time. I'm proud to say I have a Rush Holt bumper sticker on my car. I think it's going to outlast him in Congress, unfortunately. So I'm having a very hard time dealing with the idea that my congressman is going on to something else. But all of us who've had a chance to know your leadership and to have the extraordinary good fortune to know just how subtle your mind is and how gentle it is at the same time. I mean, in his letter to us telling us that he was not going to be running again, I think it was called something like Not Goodbye or something like that. Well, I know I was so angry when I saw it, I probably don't remember. But I do remember him saying in it, and I think I have this right, that it was his belief that despite the difficulties here in the Congress, he still thought that this institution was the greatest possible source or giver, you might say, or I forget the noun you used, but of social justice and public welfare. And so, while he is a rocket scientist, and it's in his bumper sticker, it's kind of hilarious, he doesn't act like that. I mean, there's a whole broad spectrum of human needs that he has mastered and led. But he has been especially good during this time when science, and particularly research, is perhaps not keeping up with the trajectories that were planned for it in terms of funding and federal support. So I was meeting the other day with the president of Stony Brook, who's a physician, an infectious disease person, and who's interested in Ebola, and there's an extraordinarily useful video by him on Ebola that we can get to you, and for me it just resembles another, as you heard when I said this the first day, another example of multidisciplinary trouble of a very different sort. But he pointed out that the extent to which we are able to deal with it, and we're not dealing with it especially well right now, is a almost direct product of the investments that we made in the HIV epidemic and before, and investments that if we don't sustain, we will probably not be able to make in the future. Our work, Congressman, does not involve typically everyone doing bench research of this sort. It represents taking doing the fundamental work that needs to happen if we're going to have citizens who have a basic understanding of science. And I know you know this because you've written for our journal and things, and then also might engage themselves in a workforce activity that involved learning in science, or might actually become part of a scientific elite. But our work really is focused on trying to make sure that people can connect what's learned here with what they need to do in the civic sphere. And you have been just an inspiration to us in your career in that particular work. And so you kind of know what the text on the plate is right already. We don't vary it by person, and I'm not going to embarrass myself again, but Bill, would you please come up here and present this to Congressman Rush Holt of New Jersey. They need to get your photo.
Okay. Excellent. Congratulations.
Thank you. Hold it up so I don't know how this is.
Oh, okay.
1, 2, 3. One more just to. Right. Perfect. Thanks.
Thank you.
Oh.
I was just thinking, if we hold it at this angle, it looks like an ellipse, doesn't it? But anyway, that's it.
Very good.
Thanks. Oh,
Congratulations.
well, this is serious. Well, it really is serious, and I thank you so much. This is it's an honor to be here with the namesake of the award, but with all of you too. I'm particularly pleased to be here with the New Jersey folks, but also those from Ohio and New York and Wisconsin and Michigan and North Carolina. Thanks for what you're doing. This is what we need. So I'm delighted to be here with you, and I'm glad to hear that the bumper sticker has some life, and that your car evidently has some life left in it. So that's, I hope my car outlasts my time here in Congress too. And I really appreciate what the West Point interdisciplinary team is doing. That's what we need, and well, I won't go through all of the awardees over the years, but as I look through the list, it is most impressive and something that I'm really pleased to be associated with. Here in Washington, we talk, well, some of us talk about the problems facing science, the fact that much of what passes for innovation in industry and in our lives these days is based on work that was done at the bench some decades ago, and that we need to put more emphasis on science research today for the future. We need more investment. We often talk, whether it's from the National Academy's report, Rising Above the Gathering Storm, or the recent report from the American Academy of Arts and Sciences, about the race that we're losing, that other countries are investing more in research, educating, by some measures anyway, better than we are. And I'm always a little bit hesitant to launch into that argument, because this is not a race. But the point is, if we do a better job in investing in science and educating people in science, we will have richer lives, intellectually, culturally richer, and also economically. That there will be real improvements in the quality of life. That's what we're talking about. Bringing science to the people for their general benefit. And that's really what you do. You help remind the scientists that the point of what they're doing is directly connected with society at large. And you're reminding the people who don't feel an affinity for science at first that science is for them too. Here on Capitol Hill, I am often identified as the scientist, or one of the few scientists in Congress. And I also feel uncomfortable with that too, because there is no reason why all of these smart people who work in the halls here, whether they are elected members or staff, there's no reason why they too can't think like scientists. And there's every reason why they should. Because thinking like scientists is really one of the best paths to democracy, to democratization. Science is democratization in a sense because it is widespread, it's egalitarian. Physicists always like to say that it's not the recognized experts that count, it's the patent clerks in Switzerland that count. Someone like Einstein, who was very much on the outs, who showed that by thinking clearly, he could do better than the experts. So it's egalitarian in that sense. But also it is democratization because science is based on advancing the common good. It's based on the idea of progress. You can learn more and more, you can understand better and better, and you can apply in ways that improve the common good. Why is this true? Well, because, number one, science is based on evidence. Evidence trumps ideology. And if you're going to live by that dictum, you have to be willing to give up cherished beliefs if the evidence is contrary. And science is based on publicly expressing your conclusions. So that, I mean, the way the philosophers talk about it is replication. But the way you and your students talk about it, I think, is checking your work and letting other people check your work. So science is a way of asking questions so they can be answered empirically and verifiably. That evidence is primary and public expression is essential so that you can avoid seeking just the evidence that confirms what you thought you already knew and thus avoid self-deception. That's why through so many of your programs, as you draw people into science and you get the scientists themselves to think about the whole point of science, you advance democracy. You advance the social good, the public good, which is what we're about here. So I get very uncomfortable when members of Congress say, well, you're a scientist, you must understand this. We lawyers, real estate agents, whatever, professions they might have, we can't understand this. Well, it's a tragedy if, in fact, that's what we've come to in this country. We have to make sure that they too, that everybody in the public and their elected officials believe that they can understand it so that they can control it, use it, and apply it for the public good. So that's why I'm so pleased to see at the poster sessions here and in all the other things what you've done that you are advancing these ends. And I commend you for it. I thank you for it. And it makes this recognition of this award, or through this award, that much more meaningful to me. Thanks. Thank you. I'll make sure you get there. Okay.
One of our colleagues, the late Paul Grobstein of Bryn Mawr College, used to say that science was about getting it less wrong. And I think one can argue that that's another way of talking about democracy. So thank you so much. It's my great honor to invite Bill to conclude our session today.
Well, again, hello all. I have some brief notes here. First, let me just introduce some friends who came to support me. These are my support team, my boosters. I'm going to ask Sharman Lawrence, James to stand briefly, Cheryl Hawkins, and Bernice Bureau. Would you please stand? These are my very good friends. From all I've seen and heard so far, this has been one exciting, productive symposium. Whenever I come to these symposia, we all talk about awardees, the science, but today I'd like to spend just maybe 1/3 of my time and say a word about David Burns. David said that's embarrassing. Please, David. You've earned it and you deserve it. I first met David probably 20 years ago. At that time, he was formulating and developing in his mind his organizing principles, I call it, of what science education should be all about. Today, many years later, David's ideas are captured in the information you've seen in many publications that states the science education should be real, relevant, rigorous, and responsible, while promoting student engagement, achievement, success, and happiness. At the time of this initial development, so I recognize someone in the back. At the time of this initial development, the scale of David's vision was truly prescient, because this was so many years ago. But David was able at that time, as we talked, as I listened to him, I could tell he could see beyond the horizon onto terrain not visible to most others. So today, 20 years later, with this symposium, this spectacular last year of service and wonderful, wonderful science education models being developed, new pedagogies being advocated and developed. I'd like to just say to my good friend David, thank you and congratulations. And next year, I will see if I can't get an award for you. Many of you may not know that, some of you may know, but many may not know that Congressman Rushholt's father was a college teacher. And I think he brings that special identification and special affinity to this group, in part based on that background. But Congressman Holt, in addition to that, I want to personally thank you for the intellectual energy, political force, prominence, and leadership that you have brought to science education and to censor in particular. Your well-known interests, presence, publications, and imprimatur has helped to energize new and experimental approaches to teaching and learning. So please accept my personal appreciation, gratitude, pride, and humility that you accepted this award. Thank you very, very much. Let me also just mention Dr. Gary Booth, who could not be with us today. David has given some summary of what Dr. Booth has contributed and accomplished. More needs to be said, but in the interest of time, I will not do that. But please recognize that Dr. Booth was a giant in this field. And to the West Point team. Colonel Sheets is with us today. I think his team at West Point consists of Dr. Kowalski, Colonel Kowalski, and Colonel Ryan. I think Second Lieutenant O'Cease, is that correct? And I just want to have a shout out to them too for the wonderful work they've done. While you were speaking, I wrote down a note that said nation building. It seems to me that the military is now being asked to do many, many things beyond the usual role of the military. And I think the approach you're taking, that sensor approach, that connecting science to the challenge of today, will play a much larger role in the future as the colonels, the generals are called upon now to do many more things beyond the usual role of the military. As a matter of fact, some 3,000 are now going to Liberia for the Ebola crisis there. So, in conclusion, let me just say that I'm happy to have been a part of this activity for the last 20 plus years, 15 plus years. And I want to say to all of the participants, all of the awardees, all attendees, this is an invitational conference. And your invitation for participation should be looked upon by you and by all of us as your certificate of appreciation.